I'm just going to record this just in case. Okay. Now, noble gas configuration is one of the ways, one of the three ways that I told you that we can do this. Okay. So noble gas notation is the following. Basically, a noble gas is the group A of the periodic table, meaning if you look at your periodic table, and everybody should have their periodic table out, it is the last column in the periodic table, the one all the way to the right. Again, you're looking at the last column all the way to the right where HE is at. Everything below HE, that is what we consider a noble gas. Okay? So HE and everything below is what we consider a noble gas. Now, noble gas notation is used to represent like kind of the inner core of the electrons and to show what are the valence electrons that are completely filled. And I'm going to show you just how to do that. So for example, let's say we're doing the spectroscopic notation for BR. Spectroscopic notation for BR would be the following. Now, again, remember, we start all the way at the bottom, we build up until we have the number of electrons that BR has. So BR has 35 electrons. This will show that this is the spectroscopic notation for BR. How about if I try to do the noble gas notation then? How is that any different from spectroscopic? So instead of doing from between 1s2 and up to 3p6, we would not do any of those. And instead we would write in brackets AR, showing that those are all the inner electrons. And then we would finish off with the spectroscopic notation of the rest of BR, and which would be the following. So noble gas notation is an even shorter way of doing electron configurations. So the whole point of this is to do it obviously in a shorter way, and shorter way. But how do you choose the correct noble gas? Okay, how do you know which one would be the correct symbol? So I want you guys to think of the game. The game is called The Price is Right. Now, I know that some of you are probably like, I've never heard of that game before. And it's okay if you haven't heard of it before. Some of you are probably like, I watched that game because it is on during the day. Okay, it is on during the day. So in The Price is Right, okay, how do you win, or how do you play The Price is Right? Basically, the host gives you like a bunch of different, like they show you a bunch of different stuff, like household stuff, like a coffee maker, a bag of chips, let's say like a blender or whatever. And what your objective, or the objective of the people playing, is you have to guess the price of those objects. However, you cannot go over the price. So let's say you say a blender was $35 and a blender is actually $34 and somebody else said 27. The person that said 27 would win because they got closest to 34 or to 30 or whatever, but they didn't surpass it. You said 34, so you surpassed the price. Okay, so you have to guess the price of an object without over guessing or basically over guessing the price. Okay, same thing here is basically you would have to look at how many electrons you're working with, and then from those electrons determine, okay, which noble gas is closer to the number of electrons but doesn't surpass the number of electrons. So for example, He, Ne, Ar, and Kr. These are how many electrons each of these have. Now I'm going to tell you right now, you don't have to worry too much about these numbers because these numbers are in the periodic table itself. So He, its atomic number is 2. Ne, its atomic number is 10. Ar, its atomic number is 18. Kr, its atomic number is 36. And xenon, or Xe, is 54. And those are the same, the atomic numbers. These are just the atomic numbers. Since noble gases don't have charges, its atomic number and its number of electrons are the same number. Okay? Again, since noble gases do not have charges, its atomic number and its noble gases, its atomic number and its number of electrons are the same. So these are just the atomic numbers of these of the noble gases. Okay? So how would you do this? The first thing is you have to, we just like we did with all the other ones, you have to determine how many electrons do I need to place. So how many electrons do I have to house? Second thing is which noble gas to use. What is the correct noble gas that I have to use? And then third is obviously after you choose the correct noble gas, you pick up in spectroscopic notation wherever that noble gas leaves off. Okay? Example. You're going to write the noble gas notation of AS. You're going to write the noble gas notation of AS. Okay? So how would I do that? Well, first, we have to determine how many electrons we have to place. So just like before, AS, we have to find its atomic number. What is the atomic number of AS? Look in the periodic table.
33.
Its atomic number is 33. That means that it has 33 protons. So then we do charge is equal to protons minus electrons. Remember, if no charge is given, charge is 0. If no charge is given, charge is 0. So this would be 0 is equal to 33 minus E. You subtract 33 from both sides. We get negative 33 equals negative E, or 33 is equal to E. So we have 33 electrons to house. We have 33 electrons to house. So before we can decide, okay, I need 33, let's look at our periodic table. Again, we're looking at the atomic number. Okay, so which of the noble gases is the last column on the right, which of the noble gases is closest to 33 but doesn't surpass 33? So you can either choose helium, neon, argon, krypton, or xenon. Which of those is closest to 33 but doesn't surpass 33?
Neon.
Well, neon is one of them, but is there one closer than neon? Remember, it's 30. Argon. Yep, argon is closer. So if you had to choose between neon and argon, your correct answer would be argon, because argon is 18 and neon is just 10. So we need the one that's closest to. So it would be argon, and we would put argon in brackets like so. Argon has 18 electrons. Okay, so next, where is my, okay, I wanted this. So next, oh my goodness, why? Oh, great. Thank you for doing that. Sorry, guys. Okay, so we said 33 electrons. We already said argon. Argon is 18. Okay, so we have to figure out where argon leaves off, right? So we have 1s2, 2s2, that would be 4. So it's 2, 4. Let me see. Let me use the pointer. Just making sure that you guys can see it. Okay. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's at 3p. Again, 2, 4, 6, 8, 10, 12, 14, 16, 18. So basically everything below 3p, everything with including 3p and below is all filled up by just writing argon, AR. So we are going to pick up wherever argon left off. Argon leaves off at after 3p. So the next one after 3p is what? What is after 3p? Anybody? What's after 3p?
4S.
4S.
Okay, yeah. So we would write 4s, 2. That would be 20 there. After 4s, we go to 3d. As you can see, 4s goes straight into 3d. And then we would choose 10 because we need all 10. That would be 30. After 3d, then we would have 4p, and we need 3 to get 33. Okay. Questions? Okay, so what I want us to do is I want us to look at number 9. Let's do number 9 together. It says give the noble gas electron configuration for S. So again, first thing is we have to figure out S's atomic number. What is the atomic number for S?
$16.
So S is number 16. That means it has 16 protons. Then we have charge, protons minus electrons. The charge, no charge is given, so the charge is 0. That would be 0 equals 16 minus E. Okay, we subtract 16 by both sides. We get negative 16 equals negative E, or 16 is equal to E. So we have 16 electrons. So again, we go back to our periodic table. What noble gas is closest to 16 but doesn't surpass 16?
Neon.
Neon, exactly. Neon would be the correct answer because neon has 10, argon has 18. Argon surpasses it, so it would be neon. And neon has 10. How do I know that's its atomic number, right? Neon's atomic number is 10. Okay, so now we just pick up where neon left off. And we have to determine that. By remember you count by 2s. So first 1s2 is, this would be 2, 4, 6, 8, 10. Again, 2, 4, 6, 8, 10. So everything from 1s2, 2s2, and 2p is completely full. Everything from 1s2, 2s2, and 2p6 is completely full. What's after 2p? That's where we pick up. What is after 2p?
$3S.
So we pick up at 3s. And that would be 2. That's 12. What's after 3s, guys?
3P.
3p, okay? And remember, we want 16. So we would just put 3p4 because that would give us the 16 that we need. Neon gives us 10, 3s2 gives us 2, that's 12. 12 plus 4 is 16. Okay, I want you guys all to try number 10 by yourselves, please. Try number 10 by yourselves. All right, guys, let's try number 10, okay? It says give the noble gas electron configuration for Se. So first thing is, just like before, we have to figure out its atomic number. What is the atomic number for Se?
34.
Mhm. That's how many protons it has. So when we do charge is equal to protons minus electrons. As you can see, no charge is given. 0 minus 34 minus E. It would be negative 34 equals negative E, or 34 electrons. All right, so we have 34 electrons. Let's check. Which noble gas is closest to 34 but doesn't surpass 34? Which noble gas would you choose?
AR.
AR, yep. Not krypton, because even though krypton is super close to it, krypton doesn't count because krypton surpasses it. So AR has 18, right? Then we have to basically pick up where that left off. So again, count. Let's count. So it would be 2, 4, 6, 8, 10, 12, 14, 16, 18. Again, 2, 4, 6, 8, 10, 12, 14, 16, 18. So that means everything between 1s and 3p is taken care of by AR. So AR has taken care of everything from 1s all the way to 3p. So we don't have to write any of those. We just have to pick up after 3p. So what is after 3p, guys? What is after 3p?
4s.
4s, exactly. So after 3p is 4s. So this would be 4s2. That would be 20. Okay. After 4s, we go straight into 3d, right? Because 4s points right to 3d. And that would be 10. We need all 10. That would be 30. Okay. After 3D, we have 4P. Okay. After 3D, we have 4P, and we just need 4 more. So it would be 4P4. That would give us 34. Questions? So what I want you guys to do for homework is I want you guys to try number 11 and number 12. Okay, try 11 and 12. The answer key for this whole worksheet is on Google Classrooms. Okay, I have another worksheet that we're going to work on for review purposes. And then we'll try like a practice quiz on most likely on Wednesday. We'll see how you do. Okay. All right, guys. That's all I have for you for today. Let me know if you have any questions. I know this can be difficult. I'll see you guys tomorrow, okay?
Bye.
Bye-bye.